So we have Parse Era, also known as Fabien Bouchard.
Hello, everyone. First, of course, thank you to Derivative. Thank you for OVO for organizing this meetup. It's first time for me to participate in a meetup, and it's so cool to be able to be surrounded with people like playing with the same tools I'm playing with, and to have someone understanding what I'm saying for the first time in my life. So that's really cool and really enjoyable. So I work as an independent artist, and I'm working mainly on creating immersive space, interactive space, but also I have a really wide range of digital art application from 3D printing, electronics, LEDs, lasers, sensors, and I'm pretty much trying to play with everything I have at hands to try to find new ways to create interaction, to make create basically emotion from data. So I'm of course using TouchDesigner in nearly every project, even if it's like this one is rendered using Unreal, but you have all the sensors are calibrating and all the data are routing through TouchDesigner. We are using NDisplay to map all the walls, and the musician I was working with is using Ableton Live, and we use TouchDesigner to be able to control all the different aspects, all the different sensor calibration, and the different part in the show. It was really like the backbone of the show. And after that, you can, thanks to the awesome Touch Engine plugin, we can really seamlessly integrate TouchDesigner into Unreal and go back and forth with textures, control parameters and everything. So it's really like really playful to work with. So that's not the point of this presentation. So these are just a few examples of what I'm doing, like really building stuff, 3D printing, experimenting. This one is using an OGD sensor to track the people going through a lobby. This one is using a tactile screen, a touch screen to let the people write messages, and it's using a laser to project the message on a phosphorescent screen. The two images under are pictures of people coming from a photo booth and integrated live into audio reactive setup that are like bouncing with the music, and so it's behind the DJ for the whole night. And you can see also the lasers on the side, and everything is done with TouchDesigner, like the laser, the projection, but also the touch screen, the photo booth, and the particles. And yeah, so I'm basically playing myself with touch in every way possible. This one is an interactive aquarium project, so this one is only a prototype, but again, it's using Unreal and TouchDesigner to be able to make my daughter draw something and scan it and render live fishes in an aquarium. So it's not well refined because it's a prototype, but again, touch is really amazing in the sense that it lets you plug anything and output anything, and you can do pretty much whatever you want. You just need some time and imagination, and thanks to the community, you can always find a way to find the proper way to do it, and there's always room for improvisation, for optimization, so it's really interesting. And now it's more interesting again because the introduction of pops. And I was thinking, like, trying to work on my presentation, and let's look at pops. And I was like sucked into it. So I was, okay, let's change my topic and let's talk a little bit about pops, because like for those who have played with particles in TouchDesigner and tried to use your GPU to render particles. We were using a lot tops to contain the data we need in the particle, like RGB. We were storing like X, Y, Y. We were trying to store velocity, forces, and everything into the tops. But now with POPs, it's made for, so it's optimized for. Sorry. Oh yeah, I will show that after. It's a link to download the example I will be showing right now. So I'm not sure I will be able to explain everything in 10 minutes. So I will show it after. It's a Google Drive. You will be able to download the examples. I will show it after again. Too late. Okay, so the first one, these three examples are quite basics because it's really just to demonstrate the logic behind the tops, the pops. Yeah, like years using tops, so yeah, I tried, as you can see, when I work for myself, I don't do like well-documented stuff, but because it's for you, I try to make something like clear. And so when you are working with pops, you are here generating points. So it's a point generator. And you can see here, we can select the shape. So I'm just basically a bit like sprinkles. I'm using a shape and tell TouchDesigner to generate this amount of points on this shape. So I have the native points for particles, and I can like deform it with noise, so my particle will spawn a bit around. And if you look with pops, you have these attributes. That's the most important part of pops. It's like each point, so pops are point operators. Each point will have these attributes. So for now, they have only P, so for position, N for normal, and N noise, it's the noise I'm introducing here. Sorry. And you can play with these attributes, and you can like mix them, you can divide them, you can really do whatever you want with them with this really important node, because this node lets you play with the attributes. You can see here, I have a lot of different operations. So, yeah, my screen is too small. Yeah, so for now, I'm just setting my initial velocity to 0, because you can change, but for this effect, it's 0. You can just put anything else, like for example, 2. And this one will say, okay, multiply the normal of these points by 2. And when I will make the particles born from these points, they will go along the normals with an initial velocity of 2. So when I said 0, it's like just born with 0 velocity, and I will let the noise apply stuff on it later. This one is also a random node. You can apply, so I create a new attribute, it's init scale, and when you look at this, you see now we have a new attribute, which is init scale. And I can, with this one, say, okay, generate your scale between 0, 3, and 2, and that's what leads to different size. Rotation, but because it's sphere, so it doesn't really matter. Random colors, same. So I create an attribute color, and I said, okay, it's float 4, and I put a noise on it, and I said, okay, make a noise, and output it into the color attribute. So I will have this noise populating the color attribute. So my points here, if you look at them, they are still the same. They just have now color because color is like a built-in attribute. And from this now I can, colors again. And from this I can start like my particle system. So I have like a way of make the particle to grow from the strip. And this is generating particles. And you can see it's really the same way as soap's particle. You are using like a feedback loop. So we have the beginning and the end of the loop. And in the middle, you can do whatever you want. So for now, I'm just using some noise. And I'm applying, I'm using as a lookup the position of the particles, making some noise on it. And I said, okay, apply this node to the position of the particle. And a second noise. And same, I'm using P as a reference, so position. And I'm outputting the noise, a curl 3D, to the position. And we go to the null, which is the end of the loop. And the particles are living inside this feedback loop. And you can see the particles also introduce new attributes. You have particle velocity, particle mass, particle life, particle ID, particle force. And that's built into this node. And you can play with this. So for here, for example, I can use the particle age and the particle lifespan, because when you create a particle, you can say, okay, live for 10 seconds each particle. So if I'm just using a math mix and say A divided by B, so A, the age, and B, the lifespan, I can get the age normalized. And from this, I'm just storing this into this new attribute. So if you look, again, a new attribute, which is age normalize. And from this, I can apply a curve, for example. So I do a curve for the life, and it's normalized. And we have this kind of noise, of node, which let you, based on the age, it's really like a lookup top. So based on the age of the particle, it will use it to scale. So they will appear really small, grew up, and then slowly fade to avoid like just appearing, disappearing. So we have a really smooth life of each particle. And for the color, it's the same. So instead of looking for a chop one, we have a look texture. So I just set a ramp for the color of my particles. And here, because I don't really color one and color two, you know, colors in the particle, when I set the noise on it, the random values, they are it's a float 4, but I'm basically using only the air, so the color 0 attribute, to look inside this. So because each particle have a random value, it will get a random color from this ramp. And so now we have all our particles with their color, their scale, their age, and their position. So from this, I can use, for example, a sphere, a copy node, which is a bit like instancing, but I think it will take too much time to really explain the difference. But keep in mind that basically instancing with a geo is a bit more optimized, but copying lets you still play with the attributes. So if you need to do other computation on the attribute, it's better to use a copy. And you can see on the copy, I'm feeding like a sphere, a pop sphere. And I said, okay, for the translation, use the attribute position, use the point scale, as I said, and we have, and I'm feeding a geo after that, and we have our spheres coming here. And I can, like, for example, switch to boxes. And if I go, I'm setting a new attribute which I called random something rotation just. So it's a random rotation for each for each particle. And I can go back to my copy after that and said, okay, for rotation, use rotation, so the attribute I just created, and so all the particles are now randomly rotated. And after that, it's really basic rendering setup, so camera, a bit of luma blur and bloom just to make some colors. And what's really important node, also really useful, is the proximity one. For those who have tried to create a plexus effect, you know, like with tops or with GLSL, it's used to take a few nodes or a few brain time to try to figure it out. And now it's just a node, you know, so you just plug your particle in it and you said, okay, give me all the proximity, like maximum 3, and I want 1 line per point, and so, you know, it's creating all this connection. You can, like, yeah, create more, or I want less distance, for example, and you can really use this for rendering. So for now, I'm using lines to render it, but you will see in another example that we can use it in much more complex way. So just for now, keep in mind that this node exists, and it can be really useful to understand when you need to calculate the distance between some particle and trying to find which are the ones that are next to each other. Okay, so I will just finish just highlighting two things really fast, because basically they are using the same logic, the other example, but just 2 different techniques. This one is to making trail, but 3D trails. So another magic nodes in POPs are the trail one. Usually you use feedback to try when you are playing with tops. You use feedback to make a trail and generate trail. And now, again, it's a simple node. So where is it? Random scale trail. So it's here. Yeah. So basically, you just plug this node, and you can say, okay, I want to make a trail for 1 second, and every frame you can add it, and yeah, you don't see it really well, but you can see it's like creating the trail for you in one node. It's really convenient, really easy. Be careful, because you can create a lot of points really easily, so don't burn your GPU with this kind of stuff. But it's really, really nice. And if you dive into this example, I won't do it now because it will take too long, but look at the way you can use it to skin the trail to make it like a 3D, a real 3D geometry. And it's, as you see, it's on my laptop, and it's 60 FPS, and it's really running really fine without any. I used to do this effect with a lot of GLSL and computation, and as you can see now, it's like just a few nodes and no code at all. It's really just trying to tune your brain to use the right logic, but yeah. POPs makes things really more efficient, optimized, and really faster to build. And just really quickly, a last one. Just to show one bit. Yeah, and I'm trying to, you know, to rush it, but try to explain POPs in 5 minutes, you know. And so this one, yeah, it's the proximity one. You've seen to create the plexus effect, but this one, I'm basically using the proximity ones to the proximity node to connect the dots, the like planets or whatever, and from this I can convert this into line strips, which is a kind of geometry in POPs, and you can divide these so I can divide into 100 another points. And I can, thanks to a lookup, I can fix the extremities so they are not moving, they stay attached to the spheres. And after I can apply noise. So because I made my lookup make the extremities stick to the spheres, I can make all the rest, like moving to make, instead of a classic plexus straight line, you have some floating lines. And again, after I can apply textures on it. So you see all these are only, it's really like cheap stuff. You know, so it's really like realms. And based on some randomness, each string will take one of those lines to get their color. And yeah, so that's really like basic and cheap effects, but it can highlight the power of pops. Again, it used to be a bit of a struggle to do this effect, and you had to have in mind a lot of GLSL and stuff, and yeah, now all the magic happens in like 10 nodes. So yeah, I really encourage you to follow some tutorials. You can go to the TouchDesigner website. There is a lot of examples, also very, very well made, and showing a wide range of application for pops. So yeah, I encourage you to play with these. And here again, the QR code. Thank you. Sorry.
Thank you very much. I have a quick question. How much sleep have you had since you opened up Pops?
Yeah, not too much.